Okay, 11. A rectangle is to be inscribed in a circle with a radius of 5 units. Find the dimensions that will maximize the area. So first of all, a rectangle is inscribed in a circle. I don't know if I can draw this, guys. There's my circle. Rectangle inscribed means my rectangle is inside. Oof, that was something like that, right? Okay. Rectangles inscribed in a circle with a radius of 5 units. So you guys know a radius goes from the center of the circle out to the edge. Because the corners of the rectangle are on the circle, that's going to be my ideal place to draw in a radius. Okay? I want to look for a place where the circle and the rectangle meet. Find the dimensions that will maximize the area. Okay. As we look at this, we're trying to look at this rectangle, yes, and we're trying to maximize the area of the rectangle. As we talk about the area of the rectangle, I'm going to use X and Y. You can use whatever, use whatever. I'm going to use X and Y. I'm going to use X as my horizontal distance. Y is my vertical distance. And so when we get ready to maximize the area, how do you find area of that rectangle? Length times width, or in other words, in my case, X times Y. Now, how are X and Y connected besides area here? Because we need something. I can't do my derivative and maximize this area when I have an equation in terms of X and Y. I need only X or only Y. And as you look here at this rectangle, what happens if I draw another five over here? What do you see in that rectangle? There is 2 triangles. And what do we know about this triangle here? If that's a right triangle, then I could use the connection that x squared plus y squared is equal to 5 and 5 is 10, and 10 squared. And this is why I'm recording on the VinQ, because it's searching. I lost Maddie and Ross. Oh, they're back. Oh. On my side, I just kept getting this annoying noise in my ear, and it kept saying searching for network. You guys were here the whole time? Okay. Okay, so x squared plus y squared equals 10 squared. So you can solve for x or y either or. Technically, I prefer to solve for I prefer to solve for y and work in terms of x just because it's what we're more comfortable with. So I'm going to say y squared equals 100 minus x squared. We're going to take the square root, of course, and say y is the square root of 100 minus x squared. Okay? So now that 100 minus x squared can go up here. So area is x. Debating, should I do? Yeah, we'll go ahead and say x square root of 100 minus x squared. In order to maximize this, we need to take the derivative, yes? I guess maybe I should have now that I think about it. As we get ready to think about derivative, this is x. What do you know about a square root? A square root is a power raised to the 1/2. So you could also think about it as x times that power, that quantity raised to 1/2. How do I take that derivative? Yep. There's a product property here. Product rule, isn't there? Derivative of the first. So I'm going to say derivative of x is 1. And then we're going to keep the 100 minus x squared raised to the 1/2. Product rule says then we add. And this time I'm going to keep the x. And we're going to multiply by derivative of 100 minus x squared raised to the 1/2. Derivative of something raised to the 1/2 is 1/2. Multiply the 1/2 out front. 100 minus x squared stays the same. Subtract 1 from your power, so 1/2 minus 1 is going to be negative 1/2 times the derivative of the inside. Derivative of negative x squared is going to be negative 2x. Did I get all my pieces here? I would go ahead and clean this up as we work to set it equal to 0. So I do have the 100 minus x squared raised to the 1/2. On this next piece, I see a minus, so I'm going to say minus. The 1/2 times 2, you guys realize the 1/2 times 2 are going to cancel each other out. X times x, so I've got x squared times 100 minus x squared raised to the negative 1/2 equaling 0. Okay. This is one where I'm not sure we've covered enough. I'm not sure we've gotten the homework examples covered like we need to here. As you look at this, we have to be able to find critical points here. Okay? And as I look, kind of think like a first half and a second half business. There's my first half, there's my second half. Think GCF. What's the obvious that there's something somehow in common? There's a 100 minus x squared, correct? Now, key is they have two different powers, don't they? This 100x squared has a positive 1/2 power. This 100x squared has a negative 1/2 power. So we need to factor out the lower of the two powers. So which is the lower power between 1/2 and negative 1/2? Negative 1/2. So I'm going to factor out a 100 minus x squared to the negative 1/2. That's my GCF I'm factoring out. Now, as I factor this GCF out, this is for the first term, it's 100 minus x squared to the positive 1/2. I'm factoring out 100 minus x squared to the negative 1/2. What's the difference in the powers? 1/2 to that negative 1/2 is a difference of 1, yes? So I have a 100 minus x squared to the 1 to the first power left. However, if I have a 100 minus x squared to the first power left, do I need to put that to the first? I don't need to put that to the first. And so what I have there is just the 100 minus x squared, and that comes from that right there. Okay? Now, we are subtracting, yes? So I'm going to say minus. Look at the second half. I'm factoring out a 100 minus x squared to the negative 1/2. When we factor out 100 minus x squared to the negative 1/2, that's exactly that piece, isn't it? What's the other piece that's left? The minus x squared here. Okay. The front piece, I'm guessing I just left as is for the moment. I did. I just left the 100 minus x squared to negative 1/2. I'm going to clean up my next piece. 100 minus x squared is going to be 100 minus 2x squared. And that's equal 0. The idea here is you set each part equal to 0, right? Trying to find our critical points, we set each part equal to 0. Now, did I even set the one? I say probably because I was just trying to squeeze everything in smally. I mean, officially you set everything equal to 0. When you go to set this one equal to 0, realize it's 1 over the square root of 100 minus x squared equals 0, right? Because that's what negative 1/2 is, isn't it? It's a square root in the denominator. Can 1 divided by this square root ever equal 0? And it doesn't. Because 1 over something is not going to equal 0. So you'll see I didn't even consider this on my answer key because it's not an issue. That piece can never equal 0. My critical point has to come from the other piece. And the other piece is the 100 minus 2x squared, setting that equal to 0. Okay, so the negative exponent piece isn't going to happen. If I solve this, negative 2x squared equals negative 100. Divide by negative 2. X squared is 50. If I take the square root, officially x is, I should officially say plus or minus, shouldn't I? However, these are dimensions, aren't they? So the negative's not going to matter. Did I mention the negative on here? See, I didn't even mention the negative on here. So x is the square root of 50. Simplified though, 50 is 25 times 2, so it is 5 square root of 2. And that 5 wrote really weird. I apologize. And I would leave it, but I'm afraid, there we go. So right there, we have, I'll put it over here, x equals 5 square root of 2. And that is the x value where our area will be maximized. Now, I'm going back to read the question. Find the dimensions that will maximize the area. My dimensions are x and y. Here's x. How can I find y? I would go back in right here. Y is the square root of 100 minus x squared. And I would use that. So y is the square root of 100 minus, what was x squared? 50. X squared was 50, yes? Can I cheat and use that? Okay. So 100 minus 50. Hey, is this 100 minus 50 is 50. Y is the square root of 50. Oh, hey, guess what? Y is 5 square root of 2. What'd you say?
Said it's a square.
So, yeah, it's a square. As I said, when you are maximizing the area, I can't say always, but it is not unusual for it to turn out to be a square.
So if we need to write our answer with the 5 square root 2 times 5 square root 2 and all that.
Officially, yes. I mean, if you have right here x and y, that works as your answer, because as long as I can see based on your drawing or whatever, that these are your dimensions. Writing it as 5 square root of 2 by 5 square root of 2 is good as well. Okay?
Are we going to see 13, 14 test yet?
I don't think so.
Because there was definitely one, a maximization rectangle one, and I remember I didn't get a square and I was freaking out about it. So I like triple checked myself. And I was like,
Yeah, and I don't. The question was just, have you guys gotten to see 13, 14 tests? And I don't think you have. And I say that because I just found them in my folder here, and I was like, why are those still there? Besides the fact Abby hasn't taken it.
Sorry.
But no, even that, because I could have shown everybody else before you came back. But I think the day right after the test, it was just, I think that lesson took incredibly long that day, and we didn't get around to it. And then that was Tuesday. Then Wednesday I wasn't here. And then by Thursday,
Things all gone back up.
it was out of our memories. So, yeah, if you individually want to take a peek at yours at the end of class, you can. So, sorry, it doesn't help having, we don't have half the class out anymore, but we still have a third of the class at home, so. Okay, that was a really good one to get through. And I will upload this recording so it will be on Schoology if anyone wants to re-listen to it tonight. In the meantime, what else should I talk about?
Eight.
What was it?
8.
8? A point moves along the x-axis such that its velocity is given by the function v of t equals natural log of t over t. Oh, excuse me, over t squared. I about goofed that up. What value of t in seconds maximizes the velocity? How are we going to maximize the velocity? Derivative, right? Similar idea to what we did last time. So we are going to use the derivative. So v prime of t. Now, the way this is set up, we're going to be practicing quotient rule. Because there's a top function and a bottom function. Derivative of the top. So what's the derivative of natural log of t? That's 1 over t. Times the denominator, so times t squared. Derivative of the top times the bottom. Minus, quotient rule is minus, and now it is derivative of the bottom, so derivative of t squared is 2t times the top, so times natural log of t, all over denominator squared. So t squared squared. Or in other words, that'll be t to the 4th here in the next step. I am going to clean that up. Actually, what I need to do is clean it up and set equal to 0, but good thing to realize here, 1 over t times t squared. If you multiply 1 over t and t squared, a t will cancel. You're going to have t minus 2t natural log of t over t to the 4th. Okay. If you catch it here, do you see what top and bottom all have in common?
T.
They all have a t in common, right? So if you catch it here, you can look at the fact that they all have a t in common, and that will, clean up a little bit nicer. So if I if we cancel a t out of everything, it's 1 minus 2 natural log of t over t cubed. At some point, we need to set this equal to 0, right? And we can either set equal to 0 here, or I wrote it in a slightly different way also, is if I put that t to the third out front. But what it comes down to, guys, what do you have to consider for a fraction to equal 0? What part of a fraction equals 0 if the fraction equals 0? The numerator, yes? And so you'll notice, whether you look at this form where I have t cubed in the denominator, I only need to look at the numerator. If I look at this would be setting both parts equal to 0, but when we looked at that earlier, 1 divided by something will never equal 0. Okay, that's not going to happen. So the part we're really looking at is, I'm going to bring it up here, so I have 1 minus 2 ln t equals 0. So if I, let's see, subtract over the 1, negative 2 natural log of t equals negative 1. If I divide the negative 2 to get the natural log of t by itself, so natural log of t is going to equal positive 1/2. And then this is where my brain goes left, right, middle, because natural log of t is what base? That's base e. So then I would say e to the 1/2 is equal to t, which is that t is equal to e to the 1/2. And for whatever reason on the answer key I said the square root of e. Excuse me. Okay. And that's going to maximize the velocity at the square root of e seconds, which I'm sure there's some decimal equivalency for that via the calculator. But without a calculator, I'm stopping right there. And I don't care which form you leave this in. They are both good forms. Okay. What else? Do we need to talk about something like number 2 and the derivative of that mess, or are we okay with that?
Are we going to have to clean it up on the mess, or can we just leave it?
Okay, Ross. What'd you say, Jacob?
I want to know if we had to clean up like number 2 or.
I think there is. I have mixed emotions on the whole cleanup question. You know, do we have to clean up? I do appreciate a little bit of cleanup. Although, and this goes back to you haven't seen the last test yet, there was one on the last test, and you were probably one of them. You kind of did it, and you didn't really clean up, and I gave credit for it. So, yeah, they were different on the one, like, I think you guys had one similar to this mess like last time, and there were different levels of cleaning up, and I didn't necessarily take off as long as all the pieces are there. So this is sine tangent squared of 3x. And I have confidence you guys can figure this out by looking at my answer key. I agree, and that was Ross's comment that, you know, give it enough time and sitting and staring at it, he can figure it out. But it doesn't hurt to have the verbal talk through too, right? Okay, so we need y prime. Overall function is sine. What is the derivative of sine of something? And that is cosine of something. So did my inside change at all? No, my inside did not change at all. So the derivative of sine of something is cosine of something times the derivative of something. So what am I trying to do the derivative of now? Tangent squared of something. So what is the derivative of tangent squared of something? Well, realize the derivative of tangent squared of something, that's not a specialty that we know. That's just something raised to the second. So how do you do the derivative of tangent squared if that's just something raised to the second? You bring the 2 out front, right? So it's 2 times tangent of 3x, and then you subtract 1 from the power, and my power is 1. So derivative of tangent squared of something is 2 tangent of something. Times, now what? We've got another something in there, don't we? The derivative of 3x is 3. Do I get all the pieces? Nope, I screwed up. Dang it. Okay, I'm going to erase the 3 for a moment. I spaced a piece. Okay. Yeah, okay, so the derivative of cosine of something, okay, derivative of sine of something is cosine of something. My something is now tangent squared, right? So now we're doing the derivative of tangent squared. So that is the derivative of something raised to the second. How do you do the derivative of something raised to the second? 2 times the something, and then now it's power 1. Times, what was that something? And this is the part I overlooked. It's so easy to overlook. What was raised to the power of 2 here? Tangent of something. What is the derivative of tangent of something? Secant squared of something. So not even looking at that, that was just the whole thing right there. So now the derivative of tangent of something is secant squared of something. Well, we've got another something here, right? So now it's time to the derivative of 3x, which is 3. Okay? So it's a lot of chain rule. And it's so easy. I just proved to you how easy it is to overlook that extra trig function in there. Okay? The cleanups I do here is the fact that there's, you know, that 2 and that 3 can make a coefficient of 6. I'll be honest, other than that, there's not a lot of cleanup there. Did I do anything else? Yeah, not really. Just 6 cosine of tangent squared of 3x times tangent of 3x times secant squared of 3x. You're learning the importance of knowing all your trig derivatives, right? They keep popping up randomly, don't they? Okay. I think we're about there on time, aren't we? I should be here for a little bit after school today. If you still have lingering questions, feel free to stop in. I should be here before school. If you have lingering questions, feel free to stop in. I should be here in homeroom. This is barring no random 2-hour delays and that kind of stuff, which you never know.
There's no chance on Wednesday for 2-hour delay at least because of the temperature. I think Doc said it was supposed to be like really cold.
Oh, I didn't know it was supposed to get that cold.
Like the negatives. That's what Doc
And
said.
then, like,
Well,
with
that
the-
would be a good. Okay, so we could be looking at 2-hour delays for temperatures. So
Where do you want our top challenges?
I will take them. Yeah, if you're leaving your AP exam practice 1 with me, I will take that
Oh.
and put it in a pile.
Can I look at my test?
Yes, and if you are wanting to look at your test real quick, I will do that. I am going to stop recording this